Okay.
I would like to introduce our online approach for haptic interaction learning with a fully-fledged robot simulation. We evaluate our approach on an example task of identifying 4 unknown objects. For each object, we define a local coordinate system or exploration zone. The robot autonomously executes primitive haptic actions, the so-called haptic glances, with the goal to identify the object class based on the resulting tactile sensor measurement. While the data is being acquired, the haptic attention model is iteratively optimized to assign a correct label to the explored zone. Here you can see a simulation of a robot arm with a tactile sensor array mounted on the end effector. This architecture aims to mimic the functionality of one human finger. In this example, the robot performs 1 haptic glance per exploration zone. Even in this simple scenario, 1 haptic glance is not sufficient for a robust estimation of the object class. To tackle this problem, our model learns to integrate tactile sensor measurements over time while adapting its exploration policy to the previously acquired data with a recurrent connection. Here you can see the robot performing a sequence of 3 haptic glances in each exploration zone, resulting in robust classification. We have conducted preliminary testing of the control scheme in real world with little readjustment in comparison to simulation. Here you can see the robot performing 1 haptic glance per exploration zone. Our future work will be dedicated to evaluation of the model tested in simulation on real data.